Okay, so our next speaker will be Benjamin Menashe from Michal Ben Shachar's lab, who happens to be in my own lab. And I'm happy to have Benji present his PhD work to us.
Hello everyone, my name is Benjamin Menashe. I am from Michal Ben Shachar's Neurobiology of Language Lab, and I'm excited to talk to you about my PhD thesis today. Expectation management cues and their subsequent effect on sentence processing. So let's start with a little bit of introduction. As you probably all know, when you process language, your brains are not passive at all. They're actually very active. You form predictions, make expressions, what words are going to come up next. And usually you're probably very good at it, but sometimes you will encounter some unexpected message, which will elicit some expectation violation, prediction error costs will come, and so on. Thankfully, language allows us to use a strategy we call expectation management. What is this? And the prediction error manifests in longer fixation times, longer reading times, a larger N per 100, and so on. We know these indices. Thankfully, language allows us to use expectation management. What is expectation management? The transmitter of the unexpected message knows ahead of time they're about to transmit something unexpected. So they warn the receiver ahead of time that something unexpected is about to happen, hopefully managing the receiver's expectations. Okay, so this, in theory, should help facilitate processing of unexpected messages, right? Because we got the warning ahead of time. But there really is no good empirical evidence that this actually works. Okay? I hope that is clear. Just a quick note, linguistic terminology. Mutative markers, what are they? We're going to use this word. It's basically a word for linguistic elements which encode the speaker's surprise, unpreparedness of mind, and so on. They're obviously widely used for expectation management. They're a language universal. In every language we looked so far, linguists looked so far, not me, but in every language we looked, we found these mutative markers. And even though mutativity can be marked using exclamatory particles, wow, or prosody or intonation, in this talk I will focus on lexical markings, and especially the word surprisingly, because we're going to deal mostly with reading. Okay? So back to our research questions. We basically have two research questions. The first one, do mutative markers alter expectations? This is kind of a sanity check. Is it even possible for it to work, right? Well, does expectation management do anything to expectation? But the second more core question of my research of my PhD thesis is, what is the subsequent effect of expectation management on cognitive real-time processing of the unexpected message? We started out with three base competing hypotheses, so let's go through them. In the first hypothesis, this kind of null hypothesis, we see in blue a transmission of a message without expectation management, right? It's a neutral condition. So an expected message has some processing, an unexpected message will have a larger processing cost. And if we append a mutative marker to the unexpected message, it doesn't do anything. There's no mitigation, okay? This is kind of the null hypothesis, as I said. A second competing hypothesis, I hope you can see people on my left, is that once you append the mutative marker, this whole extra processing cost drops, okay? This is in line with surprisal theory, which is a theory that the brain integrates all relevant information in cues to form the next prediction, variation. We have a third intermediate hypothesis, which is the dynamic mitigation of processing costs. Here, the x-axis is time. Initially, the mutative marker doesn't do any suppression of the additional processing cost of an unexpected message, but with time, it actually will suppress it, okay? I hope that is clear. Let's first answer our first question, do mutative markers even alter expectations? To do that, we did sentence completion experiments. What did we do? We basically sent out questionnaires through the internet to English speakers. We had sentences like, the birthday girl celebrated with a bottle of, and they were asked to complete the sentences, but we appended either a neutral marker or a mutative marker to these sentences, and we wanted to see the different responses. What we looked for is to see whether appending a mutative marker caused a reduction in the probability of the most expected item, right? We don't expect the most expected one, and an increase in the probability of all other lesser expected items, which actually manifests as an increase in entropy, a change in entropy of the response distribution. For those who don't know, entropy is a kind of a measurement for how wide or uniform a categorical distribution is. Okay, and this is exactly what we saw when we looked in English. The probability of the most expected word decreased once added a mutative, and the overall entropy increased. We then replicated this study in Hebrew, and we saw the exact same thing happening, cross-linguistic replication. That's very good for us. And then we replicated this study using a large language model. I'm showing here the results for Llama 3.2, but we actually found it in almost every model we looked at, so this is not anything particular. The token probability decreased, and the overall entropy of the response distribution increased. Using large language models as kind of synthetic models for human expectations in language allowed us to do a lot of analyses quickly and cheaply. We don't have to recruit humans. I'll show you a few of them. One of the things we showed is that this increase in entropy occurred for every mutative marker we checked. You can't see very well, but it has words like oddly, bizarrely, weirdly, and so on. So it's not anything special to the mutative marker we chose. And it is also unconstrained by any syntactic or semantic contextual constraint. Okay, so it's a general modification of expectations. In another study, we used the sentence embedding vectors from LLMs to show that appending a mutative marker to an unexpected sentence shifts its vector representation to make it seem more expected or less unexpected. Okay, so this was good for us. So a quick interim summary, we have strong cross-linguistic, offline human and LLM evidence that mutative markers modify expectations, and not only that, they modify expectations in the direction that would suggest they would be unexpected messages would be easier to process. Okay, yeah, but what actually happens, right? You know, it's theory is good, but we got to get some empirical data. Our first studies were self-paced reading experiments. In self-paced reading, we present stimuli to participants word by word, and the participants actually have to press the space bar to advance to the next word, and we basically measure how long till they press, like their reaction time, which is actually their reading time, and so on. So this is the design of the experiment. And we designed a simple 2x2 experiment. We had expected target words and unexpected target words, which could be preceded either by a mutative marker or a neutral marker. So just some examples, we had a king put on his head a crown, or a king put on his head a carrot, which could have been preceded by I saw that, or I was surprised at, Okay, I hope that is clear. Our results from the first study show pretty clearly that in the neutral condition, there is a longer reaction time for unexpected messages, and this difference disappears in the mutative condition. All right, yay, it works. We were very happy to see this. But being the cautious scientists that we are, and with the replication crisis looming, you know, everyone who knows me knows I like to talk about the replication crisis. We did 2 replication study experiments, and in both of them, we did not see that mutative markers had any effect. So the unexpected messages still had longer reaction time, but this was found in all conditions. We got a little bit worried. We think this is an artifact of the self-paced reading paradigm, which is not the best way to measure cognitive processing costs and so on. It's very noisy and so on. So what we decided to do is to do a joint EEG and eye tracking experiment. We did rapid serial visual presentation. It's the same 2x2 design that we had earlier, but this time words were presented for a fixed duration with fixed ISI. And we had a dual setup which allowed us for 2 dependent variables. The first one is the N400 ERP component. We know the N400 since at least the 80s and so on. And the second one is the oculomotor inhibition duration. So oculomotor inhibition, or OMI for short, is this phenomenon where the brain, where the eyes kind of freeze upon the presentation of a new stimulus, and we can see in this example participant data that there's kind of a fewer microseconds once what word was presented and so on. I will say there is no evidence, no studies up to that investigated whether OMI duration is sensitive to semantic expectation violations during reading, but it has been implicated in other cognitive processes, so we were kind of optimistic. Okay, so I hope that is clear. Let's jump straight to the results. Looking at the target word OMI, once again, we see clearly that unexpected messages had longer OMI, but this was in both the neutral condition and the mutative condition. So once again, expectation management didn't do anything to help facilitate unexpected messages. And this was also we also show this in the N400. Here the y-axis negative values go down, so lower means greater N400, and we see that the unexpected messages are lower, greater N400. There is no effect of expectation management. But, and this is the big thing, this is the big result. When we looked at the next word result, so this was a word that went after the target word in the sentence. The target word was not the final word in the sentence, there were a few other words. And importantly, the next word in the sentence, the target plus one, was the same identical word in all 4 conditions. We designed it that way, so the differences we will see are most likely due to our experimental conditions and not anything about the word itself. And we see here that our condition of interest, the mutative unexpected condition, right, the unexpected message with a mutative marker, actually did decrease greatly. And here we have a significant interaction effect. While all other conditions stay the same, we see the spillover effects the same. And if we plot both of these data on one plot, so here we have both the data on one plot, we only use the three conditions for which we had hypotheses for, so target and target plus one. We can see that initially expectation management still has longer processing costs for unexpected messages, but it is soon suppressed. And I hope you can appreciate how similar it is to the dynamic mitigation hypothesis I presented to you. So yeah, that's a big result I wanted to show you. I will take one more minute of your time to talk about an unlikely connection found in the literature with counterfactual world processing. So essentially, they did these researchers did a study where they had anomaly, consistent and inconsistent conditions. So if the cat is hungry, you can feed it fish, and if the cat is hungry, you can feed it carrots. But then they presented a counterfactual world in which the anomaly is actually not anomalous. If the cat was vegetarian, you could feed it carrots. Okay, and I hope you can appreciate also that there's a similarity here in how we modify the context in order to make an unexpected or incongruent message less unexpected. I won't go into the results, but due to lack of time, but I will read you what they wrote. And they wrote that results show that initially there was a disruption to eye tracking even when the anomaly fitted the counterfactual world context. So there was an initial disruption, but shortly after that, the counterfactual world context accommodated the anomaly completely. So very much fitting with what we found. So in conclusion, our results suggest kind of a hierarchy of expectation, and I'm using that word loosely, but they're basically the default, information only, real world only maybe, expectation, and then mirror marker expectation management strategies as secondary expectation modifiers, which come on top of that. And this will manifest as a dynamic modulation of processing costs, right? So there's something that's happening across time. We believe this explains the discrepancies between our real-time target results and our offline behavioral experiments, which I showed you earlier. This adds to the growing body of evidence challenging surprisal theory, right? Our brains are not immediately perfectly Bayesian. There is some process going on there. And it has interesting implications for the uniform information density theory of communication, which I didn't go into due to lack of time. I will also say that I have a poster presenting about results in expectation management in non-linguistic domain, if anyone is interested to speak to me later. And I want to say thanks. First of all, thank you to you, my audience. Thank you to my students, my friends, my professors, my lab members. And I want to say a very special thank you to Micha, my supervisor and mentor, for teaching me how to be a better scientist, but more importantly, how to be a better human being. So, Micha.